We're now moving on to comparison operators. Comparison operators have functionality such as checking for equality, not equal to, less than, greater than, equal to, and they're basically used within programs to make decisions, so influence the flow within the program and the logic within the program. We'll now start looking at comparison operators. These are as follows: equals, not equals, less than or equal to, greater than, and greater than or equal to. So say we have an integer a equal 10, another one b equal, say 20, and we assign the result to c, and we say a equal to b. So what we're doing is checking, is a equal to b, and then assigning the result back to c. So the result will be a Boolean, which is either true or false. A is 10, b is 20, so they're not equal to each other. So you would expect c to be false when we print out the result. So we run the program, you see false is returned. If a was equal to 20, so we then have 20 is equal to 20, the answer would be true in this case. The not equals operator here would be checking the opposite. So we're saying, is a not equal to b? Well, here they are both equal to each other, so the result would be false. If a was, say, 21, so therefore 21 is not equal to 20, you would get the result true. You have the less than operator. So here we're checking, is a less than 21? Sorry, is 21 less than 20? It's not, so we'd expect the answer to be false. But say b was 22, in which case a is less than b, 21 is less than 22, so we get the result equal true. We also have the less than equal to operator. So here a is less than or equal to b, so you get true, but if they were equal to each other, you'd also get true in this situation, because a is less than or equal to b. If a was, for example, 30 in this case, 30 is not less than or equal to 22, so you'd get false. The greater than and greater than equal to would likewise behave in similar ways. The comparison operators also apply to float types of numbers and strings. So I'll give you some examples. Say we had a float number 3.222 and another one as follows. You could do a comparison of equality. And when you run this, you would get false, as the variable a and variable b are not equal. You could, if you use the not equals comparison operator, you would get the result true. You can also use the greater than operator. Here a is greater than b, so you get true. And you could also use greater than equals to operator. So all the comparison operators equally apply to real numbers. One thing to note is safer when comparing real numbers for equality to use a tolerance technique. This just really applies because numbers, when stored in floating point, are not always stored with the precision you see on the screens. So I'll show you this. So we have two float number variables with the same value, and to do a comparison based on tolerance, we would do the following. We'd find the absolute of the variable b minus a. So what we're doing here is taking the variable b, subtracting a from it. Now this could be a positive or a negative number, and we use absolute to get the positive, force the result of that calculation to be positive, and then you use a tolerance to say whether you believe the numbers are equal or not. So as long as them two numbers are close enough such that when you subtract them, the difference is less than this tolerance figure here, you'd use this to determine equality. So this is a safer way of checking equality for real numbers, just due to the way real numbers or floating numbers are stored in memory, and the method of storing their precision. So when we run this, you get true. If they were slightly different, say b has been changed to 1.112, you'll get false. The comparison operators also work with strings, so I'll give you some examples. So we have a string variable a which has a value Bob, and another string variable that has a value Bull. You could do a comparison as follows. Which will give you the value false because the variable a and variable b do not equal each other. You can run the inequality check, and that's true because they don't equal. You can also use all the other comparison operators such as less than, greater than, less than, equal to, greater than, equal to. What you'll notice is when you run this here, a is not less than b, because the way the comparison works is it takes one letter at a time and checks whether it is considered less than the same letter in the other word at the same position. Alphabetically, a is less than o, so, and how it's stored in code in memory is aligned with this. So b is considered less than a, so we get false in this comparison here. Whereas if we had a is greater than b, we'd get true. If they were both had the value Bob, again, you get false because they're equal. If you change the case so that the variable a has an uppercase b, you'll find that the comparison a less than b returns true, because the way letters are stored in memory, this is using Unicode method of storage, the uppercase letter b is considered less than lowercase b. So here, Bob with uppercase b is considered less than the variable b with lowercase b. In the next lesson, we'll move on to logical operators.